are you, my friends? This is lecture number 20 of the Calculus 1 lectures about curve sketching and asymptotes. We have seen simple curve sketching in lecture 18, I think, and this is lecture number 20. In the objectives, we will see infinite limits. From there, we will deduce the vertical asymptotes, and limits at infinity, we will look at the horizontal asymptotes. And this is the method, the steps for curve sketching we have seen before, but these are the general one. Critical points, increasing and decreasing, possible inflection points, intervals of concavity, x and y intercepts, asymptotes, and the behavior at infinity. This is everything you need for the curve sketching. Infinite limits and vertical asymptotes. This is in lecture 4. We have seen some of these questions. Recall that f of x is said to increase without bound. So the function itself will go to infinity as x approaches a. Then we can write the limit of f of x as x goes to a will be plus infinity. So the limit here is infinite. We say infinite limit. So the limit is either plus infinity or minus infinity. Also, f of x decreases without bound or becomes negatively infinite as x goes to a. Then we can write the limit of f of x as x goes to a is minus infinity. So if the answer in the limit is infinite, either plus infinity or minus infinity, then we can say x equals a. Look at this. This is a vertical line. This is a vertical asymptote of the curve. On the graph, you will see x equals a is a vertical asymptote of the function y equals f of x, provided either we have the limit from the left or from the right, plus infinity or minus infinity. Let's look at one example we have seen similar to this one. Find the limit of 1 over x plus 2 squared as x goes to minus 2, and find any vertical asymptote. If we replace here x by minus 2, see we are coming to minus 2, x approaches minus 2. So we are approaching 0 in the denominator. See, we have seen the graph like this before. Even if you don't know the graph, if you are approach x goes to minus 2, so this will be close to 0. When you square it, it will be positive number. So 1 over close to 0, positive number, it will be plus infinity. So that means if we come to the minus 2 from the right or left, it will be plus infinity up. See the graph, both, it will go positive infinity. So we can conclude or deduce that x equals minus 2, this number a here, is a vertical asymptote. Let's see another one here. Find the limit of x divided by x plus 2 all squared. Little different. And find any vertical asymptote. If we try to substitute here x minus 2, so we can put here minus 2. See, all the numerator is negative now. You see? In the other question, example 1, it was plus 1 there. And here we put minus 2. So this will be close to 0, but we have a squared, so that's a positive. See, it will go close to 0 here. And here we have a negative number, and this will go approximately 0. So it will be negative infinity. Also, we can conclude that this is a vertical asymptote. We will graph similar to these functions at the end of this lecture. Now, limits at infinity. Here f of x approaches a number L. So here limits at infinity is different from infinite limits, guys. Limits at infinity here, the limit is a number as x goes to plus infinity or minus infinity. So this is like you travel to infinity, limits at infinity. You go there at infinity, and then you find the limit there. It will be a number. So f of x approaches the number L as x increases without bound. X is increasing, remember here. So we have the limit of the function as x goes to plus infinity or x goes to minus infinity. Both will be L, a number. So we can say we have horizontal. See, x goes to plus infinity means we go in the direction of the positive x. X goes to minus infinity, we go in the direction of the negative x. Then we can conclude that horizontal asymptote y equals L. That's a line here. See this red line here. This is a horizontal asymptote, HA of the curve y equals f of x. Let's look at this question here. Find the limit of all this 3x cubed minus x divided by 2x cubed plus 7x squared minus 4 as x goes to plus infinity, and find any horizontal asymptote if there is any. So when we find the limit as x goes to plus infinity or minus infinity, there is a nice method you can learn always. This is the method here. Divide each term in both numerator and denominator by the highest power of x that appears in any of the terms, up or down. Just pick up the highest. What is the highest power here? The cube. So we divide each term. You see here, this term up, this term, this term, this term. So you can use this method when you find the limit of a function as x goes to plus infinity or minus infinity. Now you simplify. When you divide here by x cubed, it will be 3 minus 1 over x squared. Down here we have 2 plus 7 over x minus 4 over x cubed. Now you apply the limit laws. This is 3 minus 1 over infinity, even 1 over infinity squared. It will be 1 over big number. So it will be close to 0. So that's 3 minus 0. Here we have 2. That's a constant. 7 over infinity or minus 4 over infinity cubed. So this will be 7 over big number, 7 over big number, 4 over big number cubed. It will be 3 minus 0 divided by 2 plus 0 minus 0. So it will be 3 over 2. That is L. So we have y equals 3 over 2 is a horizontal asymptote if you try to graph this function. Curve sketching, the steps are, we have seen many times before, even in the objectives. So you can read these critical points, remember, should be in the domain, increasing and decreasing. Inflection points, they come from f double prime, where they change concavity, the intervals of concavity, etc., etc. Vertical asymptotes, horizontal asymptotes, if there is any. Remember, vertical asymptotes, infinite limits. Horizontal asymptotes, limit at infinity. I will present for you here 2 examples, 4 and 5, about graphing or curve sketching. In the solved questions and other videos, you will see at least 3 or 4 videos there on more and more graphing. Let's start with this maybe easy example. F of x is equal x divided by x minus 2. Then example number 5 will be a little harder. Now, usually we start by finding the first and second derivatives of the function that we need to graph. So let's start directly. We look at the function, it will be x over x minus 2, so we can use quotient rule here, u prime v minus v prime u divided by v squared. This is from lecture number 7. So the derivative of the x will be 1 times x minus 2 minus x minus 2 prime, which is the derivative here is 1 also, times the x over x minus 2 squared. This is v squared. Now here you simplify, x minus 2 minus x will be minus 2 over x minus 2 squared. This is f prime. Now, again, f prime, you can use quotient rule if you like. You can use also reciprocal rule. I used here the quotient rule, the derivative of minus 2 times x minus 2 squared minus the derivative here, see this one? The derivative of x minus 2 squared divided by minus 2. This is the numerator u. Divided by v squared. Here x minus 2 squared is the v, so it will be x minus 2 to the power 4. Simplify up, this is 0 times this will be 0. Cancel here x minus 2 only, so we get f double prime 4 over x minus 2 cubed. Now take f prime, f double prime on the next slide. So clearly here we can see no critical points. See, f prime is never 0. Try to put f prime is equal to 0. So there is no critical points, because the critical points should be in the domain and f prime is equal to 0. This is never 0. No inflection points. F double prime is never 0 here. Also put this one is equal to 0. You get no values for any x. Now let's study f prime. So f prime here, it's minus 2 over x minus 2 squared. So f prime, you see f prime, this is positive down here, x minus 2 all squared. And we have a negative, so it's negative for all x. Then f is decreasing. See, f is decreasing because it's negative always. From minus infinity to 2, union 2 to infinity. Because 2 is not in the domain here, you see. If you put 2, the domain will be all real numbers except 2. F is not increasing because f prime cannot be positive. F prime cannot be positive. Any number x you put in f prime, it will be always negative. Now, we finish now increasing and decreasing. Let's see the concavity. F double prime, this is f double prime, negative, where it is negative. This is 4 positive over, this is cube. So we have squared, x minus 2 squared, we have x minus 2. So the x minus 2 squared is positive also, so we can consider only x minus 2. So if f double prime is less than 0, x minus 2 is less than 0, take 2 on the other side, x will be less than 2. So this is negative. The function concaves downward on minus infinity to 2. Same thing, if f double prime is positive, that means x minus 2 should be positive, greater than 0. So x greater than 2. So the function f concaves upward on greater than 2 means 2 to plus infinity. On this slide, we will find the vertical asymptotes and any horizontal asymptotes. So we see if the limit of this function x over x minus 2 as x goes to plus 2 from the right or 2 from the left. 2 from the right, it will be plus infinity. Why? Because this is a positive number greater than 2. So this will be a number minus 2. So that's a positive, and this one is a positive. If x goes to the limit, x goes to 2 from the left. So that will be a negative number here. And this is a positive number. So that will be minus infinity. So x equals 2 is a vertical asymptotes. Now the horizontal asymptotes, which is the limit of the function as x goes to plus or minus infinity, we divide by any term with the highest power. So divide by x. So this will be 1 over 1 minus 2 over infinity, which is 0 here. So it will be 1. So y equals 1 is a horizontal asymptote. Now we look at the graph. All the values here we have found. I put it in one slide here with the graph. So we have a horizontal asymptote. We have a one vertical asymptote. We have the x-intercept here, easy to find x-intercept and y-intercept. And that's the function, rational function. Example number 5 is a little harder. Let's sketch 3x divided by x squared plus 1. As usual, we can start with the first derivative. So in this slide, see, it takes here little steps. So it took the whole slide only to find f prime here. But we have the formula there, quotient rule. I explained many times. You can do it yourself. 3x prime, just read it and check it, times x squared plus 1. This is the v minus the derivative of x squared plus 1 prime. All this prime here, 3x divided by x squared plus 1 squared. Continue, this is 3 multiplied by that. This is minus from the formula. The derivative here is 2x times 3x will be 6x squared. Here we have 3x squared plus 3. So it will be 3 minus 3x squared over x squared plus 1 all squared. This is f prime. Here we will have critical values and critical points. Let's work now on the second derivative. Also one slide, the second derivative. From f prime, we have to find the derivative of this. It will take time to do this. So also we can use quotient rule. So f prime here, 3 minus 3x squared from the previous slide divided by x squared plus 1. I will show it to you here. See this down here? It is there. 3 minus 3x squared divided by x squared plus 1 all squared. So this is u, this is v. So let's go. 3 minus 3x squared prime times x squared plus 1 squared minus. See, there is a prime here, small prime. This one is clear. Listen from the typing here. But there is a prime here, x squared plus 1 all squared prime times 3 minus 3x squared divided by all this squared. So it becomes power 4. Let's see here. Minus 6x, that's the derivative. Leave this one here. Now minus is there. This is 2 x squared plus 1. Then 2 minus 1. So that's why we have x squared plus 1 times the derivative inside by chain rule. This is 2x times all this u, which is 3 minus 3x squared. Now, what do we have here? We can have 2x is a common factor. You see this 2x? Okay, leave this minus 2 there inside. There is a 2x here, and there is a 2x there. So you can leave minus 3 inside. Also, there is x squared plus 1. Here we have squared, here we have power 1. So we can take x squared plus 1 common factor before we simplify to make it easy. So I can take 2x, x squared plus 1, all as a common factor. Now what's left inside? I'll go back. Sorry for my finger. Minus 3. See, this is minus 3 times x squared plus 1 minus 2 here times all this 3 minus 3x squared. So now we can cancel here one of these x squared plus 1. This is power 4. This is power 1. So down we have it power 3. And leave the 2x there. Inside here we say minus 3x squared minus 3 minus 6 plus 6x squared. So this becomes, this is 3, right? 3x squared minus 9. So we can take also 3 out. It will be 6x x squared minus 3 over x squared plus 1 all cubed. Now you can check it, please, and study it. Make sure you get this f double prime. You know, critical values, you can get them from f prime is equal to 0 here. Take 3 outside, and then 1 minus x squared, you can factor it, difference between two squares. So 1 minus x, 1 plus x, you put them on the table, and then you choose a number between minus infinity and minus 1. If you choose any number, let's say minus 5, this will be positive, this will be negative. Between minus 1 and 1, you can choose a 0. It will be positive and positive. Greater than 1, you can choose 7 or 50. Okay, so f prime now is negative. That means f is decreasing. F prime is positive. That means f is increasing. F prime is negative. That means f is decreasing. So we can see f prime is negative where? From minus infinity to minus 1 and 1 to infinity. You can write also union if you like. This is a decreasing. F prime is positive, so F is increasing on -1 to 1. So here we have decreasing and increasing, so there is a local minimum at -1. To find the minimum itself, you put -1 in the function here, so it will be -3/2. Local maximum here we have, because we have increasing and then decreasing, this is local max at x equals 1. To find the maximum itself, put 1 in the function here, so it will be 3/2. Now to study f double prime, we put f double prime is equal to 0. We get 3 values for the x equals to 0 there, and then x will be plus or minus square root of 3. So there are 3 possible inflection points, and this 3 is the step 4, you see, but we have, it happened, we have 3 with the step 3. So let's do a table of signs for f double prime. So we put x minus 3, x plus 3. You know how to do the table of signs. Many times we have done this. So we put a negative number there, and then we have minus f double prime is negative. That means the function itself will concave down. F double prime here is positive. Between this number and this number, it will concave up, then concave down, then concave up. See how many times we have changes? We have one change here, one change here, one change here. So f double prime is negative. F concaves downward from minus infinity to minus square root of 3, union negative also from 0 to square root of 3. F prime is positive where? From minus square root of 3 to 0. This is concaving upward, union square root of 3 to infinity. So we can expect here we have 3 inflection points. This one, x is minus square root of 3, another x 0, another x square root of 3. Each x from here, we replace it in the function itself, in f of x. So we will get here, this is the image, the value of the y, minus 3 square root of 3 divided by 4, or we get 0, 0, or we get square root of 3 square root of 3 divided by 4. Now this is a rational function. Let's continue easily with x-intercept. Let y is equal to 0. Easy. Y-intercept, let x equal to 0. No vertical asymptotes. This is a little nice here. Why we don't have any vertical? Because the denominator here cannot be 0. You see? X squared plus 1. Denominator cannot be 0. Suppose we have x squared minus 1. So we can expect 2 vertical asymptotes, x equals 1 and x equals minus 1. Let's see any horizontal asymptote. As we remember, in the horizontal, the limit of the function as x goes to plus or minus infinity, we divide by the highest power. Divide 3x by x squared, divide x squared over x squared, divide 1 by x squared. So we'll get 3 over infinity, that's 0. 1 is 1 constant. 1 over infinity is 0. So it will be 0. So if the limit of the function as x goes to plus or minus infinity is a number, this is L, that means y equals the L, the 0, which is the x-axis itself. Y equals 0. That's a horizontal asymptote. Now you might say, guys, that this example 5 is too long. Yes, but in the exam, maybe you will have part of these as a question, or only the asymptotes, or only the derivatives, or only the inflection points, or only increasing or decreasing. But here you are studying everything you need about this graph. Now, this is the final graph of this. F of x, 3x divided by x squared plus 1. I will talk about this last question to ask, but let me just concentrate now on the graph. See, we have horizontal asymptote here. We have found y equals 0. No vertical. We have local maximum here, 1, 3 over 2, 1.5, local minimum. This is already global max and min because these are the highest numbers. The function will go here, asymptote at the x-axis, also from this side. We have to check one thing, every rational function. Does the graph cut the horizontal asymptote? So what do? Maybe yes, maybe no. So we take the function itself, this is the function, equals horizontal asymptote that we have found. We have found horizontal from here, guys. Horizontal asymptote y equals 0. So I put y equals 0, this is horizontal, equals the function itself. Then I try to find x. If there is an x value, that means the graph will cut the horizontal asymptote at that number. Maybe 2 values for the x, maybe no values for the x. Maybe we get 5 is equal minus 6, or 0 equals 7, or something impossible. That means there is no x. If we have no value for the x, that means the graph will never cut the horizontal asymptote. But in this case, yes, the graph cuts the horizontal asymptote at the point 0, 0, because we found x equals 0 from here. It can be another value, maybe x equals 1, or x equals half, or x equals minus 6. Then you take that number, put it in the function here, you will get the y value. But it happened here that the graph will cut the horizontal asymptote at the origin, 0, 0. For more questions, please, you can check the playlist Calculus 1 Solved Questions to understand the lectures better. This is the end of lecture number 20 of the Calculus 1 lectures. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.